In this tutorial, I'm actually going to show you how to use the Magma Chamber Simulator to run a simulation. So for this, first we need to navigate to our Finder, then our Documents, and open up the MCS folder structure. So the Magma Chamber Simulator, as you saw in a prior tutorial, is here in the MCS VBL code folder. We can go ahead and open it up and enable macros. Now I'm going to make this a little bit bigger so you can kind of see what's going on. The first thing we need to do is open up your MELTS terminal command window. So the nice thing about the Magma Chamber Simulator is that it literally tells you step by step what to do. So step 1, we choose our MELTS terminal commands. Step 2, create our archive file. Step 3, find the wall rock, solidus, and liquidus parameters. Step 4, actually do the model. And then step 5, we can export our model results. So for step 1, we are going to make 3 different MELTS batch terminal windows. So we can go ahead and click on this button, and it pops up a user form. Now, depending on what you're modeling and depending on your preferences, what you're actually trying to do, your compositions, things like that, you'll pick different versions of MELTS to run. So in the Magma Chamber Simulator, you can run 3 different versions of Rhyolite-MELTS as well as pmelts. So you can either run Rhyolite-MELTS version 1.0.2, 1.1.0, or 1.2.0. So if you're not sure which version you need to use, you can go online to the OFM Research website, and Mark Yorso's got some handy-dandy spreadsheets and flowcharts to help you select which version of Rhyolite-MELTS you need to use. For this, we're actually going to use version 1.2.0. Now, there's some MELTS batch executable text here. So where do we put it? We need to open up the terminal window. And we need to have 3 different terminal windows running at once. So I can press Command T twice to open up some new terminal windows. And I'm just going to do a little bit of reorganizing here. For the Magma composition, we're going to have 1 batch terminal running for that. So I can click the Put in Clipboard button. This automatically copies all of the text and puts it onto the clipboard. So we can click on our first terminal window and press Command V to paste it. Then we're going to go to our next tab, do the same thing for our wall rock MELTS batch terminal, and the same thing for our recharge MELTS batch terminal. So we're running the same version of MELTS 3 times, once for the recharge, once for the wall rock, and once for the magma composition. And then they'll talk to each other, kind of using the Magma Chamber Simulator as an intermediary. After you've gotten this part done, you can go ahead and close out this window. The next step is to create your MCS archive file. So this is the name of the file that you want to remember this by. This is what all of your output data will be saved as. Now, a limitation of Excel 2011 is that when you're creating these files, you can only have 6 characters. So here at UCSB, we've actually done this schematic where we have the date, the month, and then some letter, whatever number run you're on. So today's October 7th. This is my 5th run of the day. So I'm going to type 7, OCT for October, and E for my 5th run. So date, month, and then whatever run you're on. So this does limit you to 26 runs a day, but trust me, you're not going to want to do any more than that. These can take quite a while, and I mean, if you do end up doing more than 26 runs in a day, you can come up with some other naming schematic, do whatever you want, but as a reminder, you are limited to 6 characters. The next thing we need to do is figure out what our input file is going to be. So we have this drop-down menu. If you click it, it will actually bring up all of the possible input files that are in the input and output folder. So for this run, we're going to do a 3 recharge event run, so an R3FC, and it's going to have a carbonatite in it, or at least a carbonate magma. So I can click New MCS Archive, and it'll think. And now that's set up. So the next step we need to do is to find our wall rock solidus. you'll notice down here in the bottom left that there's some text, and that'll change. And that kind of keeps you advised of what's actually going on. So when you click the button and you think, oh, nothing's happened, check down here. It'll say, oh, well, now you're cleaning up the XML processed files, just in case you forgot to empty them after your last run. So if you're not sure if the MCS is working, check down here in this area. You'll see that there's likely some little text going on and that the Magma Chamber Simulator is actually thinking. Another way to know that it's thinking is by going over here to your batch terminals. So you'll see here that the temperature of the wall rock actually is changing, as well as the percent of liquid that's accumulated in the wall rock. If you look over here at the wall rock melts batch terminal, it's thinking. There's this little scrolly wheel, there's some text going on, and it's updating you as to what MELTS is doing at every temperature step. You can also look at the graphs. So in MCS, we have graphs built in. They don't automatically come up though, and you have to press show graphs. And I'll show you that in just a second because our wall rock is primed. So this is the window that pops up when it's done priming, and it says, oh look, the wall rock's primed at 1075 degrees C. At that temperature, the wall rock is 9.64% liquid, and the highest temperature at which there's no liquid, so the solidus, is 925 degrees. Now, if I had wanted to look at the graph while the wall rock was priming, I would click show graphs. Now this doesn't automatically refresh, which is kind of annoying, but there's no way to actually do that, unfortunately. So you do have to keep clicking that button if you want to update it manually. And you'll see here we've got a plot of our temperature versus the percent liquid in our wall rock. So once our wall rock is primed, we can run the MCS. If you're not sure what to do, you can follow the numbered steps, or down here in the bottom left-hand corner, it says, oh look, our wall rock solidus is complete. Next, you're going to run the MCS. So we can click on that button. And it's thinking. We know it's thinking because now our MELTS batch terminal for the Magma subsystem is thinking. We've got a little rolly circle, we've got some more text, and you know that some things are going on. Also, we have a temperature here in the Magma temperature. Right now, it's at 1064.8 degrees. And we've got a temperature decrement of 5 degrees, so every temperature step we're going to cool, we're going to go 5 degrees. Now it's dropped 2 temperature steps. The new magma temperature is 1054.8 degrees. We can also show graphs. So I'm going to zoom out just a smidge here so you can actually see all of the graphs. If I click show graphs, there are excuse me, Harker plots that come up. In the input files, if you scroll all the way to the very bottom below the 5th recharge input, there are inputs for whatever graphs you want to do. You can do pretty much any major oxide versus any major oxide, and then it will automatically plot those Harkers for you. And you can manually update them so you can watch the composition change during the run. And we're waiting. And this is pretty much what happens. But look over here, we've got some activity on the right hand side. This is our MELTS batch terminal for the recharge composition. And it looks like we've had our first recharge event. For this recharge event, we've dropped in a partially carbonatitic magma that's very low temperature. So our new temperature is going to be 965.12 degrees. And if we click on show graphs, you can see, hey, there's a really big jump in composition, and that's exactly what we would expect with a recharge event. Now, another thing that you should know about the recharge events using the Magma Chamber Simulator is that this isn't, you know, a stereotypical out in the field, oh, recharge, there's some mingling, there's some mixing, there's some incomplete hybridization. Because MELTS operates on thermodynamic equilibrium, at every temperature step, your new magma composition is completely hybridized and runs to thermodynamic equilibrium. So the new hybridized magma composition after the recharge event has some new hybridized temperature as well, and it will have a new mineral assemblage. And those are all different things that you can see in the output file after our run is complete. So at this point, I kind of like to take a little break, go to the bathroom, get a snack. These things can tend to take a while. So I'm going to press pause, go get yourself a drink, go to the bathroom, have a cookie, enjoy the run, and come back in a second. Okay, we've already done 2 recharge events here, and now we're at our 3rd. If you look at the composition, it might not look like it, but our first recharge event was a carbonatite magma. Our second recharge event was more of our original basalt, and our third recharge event is more carbonatite magma. So we've got some funky business going on here in our Harker plots. And now pretty much this is just going to fractionally crystallize for the rest of the run. So I'll zoom in so you can kind of watch the magma composition and the magma temperature. So I'll zoom out just a smidge. And I think I've had to set a hard stop here. I believe it's at 850 degrees, although it could be at 800 degrees. So at this point, it's just going to keep cooling and cooling and cooling, either until it hits the hard stop temperature, if one has been put in, or until the wall rock subsystem and the magma subsystem are thermally equilibrated. And usually that's at a pretty low temperature, depending, of course, on your input parameters. So I'm going to press pause here, and I'll bring you back once the run has been completed. All right, so I had set my hard stop at 850 degrees. And once that happens, or once the wall rock and magma are thermally equilibrated, we get this nice little window that pops up and says, hey, your run's complete. Congratulations, you haven't had any quad errors in your MCS run. Actually, no, that's a big congratulations. These things can be quite finicky. If you do happen to get a quad error, your run doesn't go to completion, don't get discouraged. There are little tips and tricks that you get to use. With experience, you get to know them more. Things like maybe switching your temperature decrement a little bit, changing your mass, just, 1 or 2 grams. Little things like that. If you've played around, you're still absolutely stuck, make sure that you've run your compositions through standalone melts. It could be a situation where your composition might not run in that version of melts, or there might be something funky with your composition. So by running everything through standalone melts first, just doing, FC or EC only, with the whatever pressure and oxygen fugacity conditions you're going to be running your MCS model at, you can kind of get away from those quad errors and minimize their occurrence. So our run is complete. When the temperature of the magma is 850 degrees, or in this case it's just below 850 degrees, it's one temperature step below 850, then it gives you the magma temperature and the wall rock temperature, and you're almost finished. The next thing to do, the last thing we have to do, is to export our data. So we're going to click OK and export run results. Now it's perfectly normal for the screen to flash a little bit. In fact, it says export will take a few seconds with cursor flash. And that's it. So now all of your data has been saved in an output file. It's saved as 7 October E. Remember, that's what we named our file at the beginning of this run. And you can click OK. Now I'm just going to reiterate this. I reiterate this every single time. When you're ready to close out the Magma Chamber Simulator, do not save the file. It's a macro. It's built into the worksheet. The worksheet itself is the macro. So if you save the file, you've saved this run and you can't do a new one. What I like to do actually is I duplicate my MCS file and just save it as, MCS backup copy. And then if I accidentally save over it, which I inadvertently do, and everybody will at one point or another, you already have a backup file. You don't have to go and re-download the entire folder structure. So do not save the file. And if we go back into our input and output folder, you'll see that, hey, our file has been saved here. So now we have, in addition to our input files, we have our output file, 7 October E. In our next tutorial video, I'm going to walk you through how to read an output file. So we'll take a look at exactly what's happened during this simulation.